Good morning. Now we are with third part for the orals and we are switching over to unit number 2. So just we will first revise the things we are seen. So we have seen stress, strain, then their suffixes, their units, then relationship between three moduli without mu. Then we have volumetric strain, then Poisson's ratio, determinate, indeterminate, and then temperature stresses. Now we are with the most important, you have questions on this, and we have that is SFD, BMD, shear force diagram and bending moment diagram. Now generally questions you have been asked are generally standard cases without values. So which are standard cases? So you have this will be cantilever beam and with concentrated load. So we have this will be W. So now whenever we have this, so if you will see, then we are going to get for this, if I will draw the reactions, then we have reaction will be W over here. And if I will say this is L, then moment due to this is clockwise. So we will get here anti-clockwise moment W into L. And then if you will draw the shear force diagram, then you know we will start from here, we will go up, then no load, then we will go till free end, and then we are in this fashion. So we have this will be on positive side. This is our baseline. And this value we have W. This is my SFT. Now BMD, we have to draw up or down, then that depends upon your movement. If we will consider directly by this, then you can see, so we have this, I will consider a small portion, and if we will plot it, it will be in anti-clockwise direction. Take your body in downward direction. So we are being in this fashion. So we have this will be W into L, and if we will see, bending moment at free end is always 0. So this is my value. So you can say this is minus. So we are in this fashion. So this is XX. Now we have plotted this BMD on compression side. So we have W into L. So we have here no load between A to B. So in SFD, we have x to the power 0 polynomial function. And here we have x to the power 1. It is increasing by 1. All these standard cases you should know. I already mentioned you have to draw, you have to write all this and upload on our Google Classroom. So now we have this will be another. So we are with UDL. So now we know this is W, this is L, this is A. Now if you will find reactions, then we have reaction, that is total reaction we will have W into L, total load over here. So total load we have area of this rectangle, W into L. What will be moment? We know W into L by 2. So this will be WL square by 2. As due to loading it is clockwise, so we will get here anti-clockwise. Now we will go with SFD and BMD. So now we will start from here. So we have W into L upward. No, we have value is decreasing, and therefore we have this will be 0 over here. So this is x to the power 0. Here we will get x to the power 1. And now BMD, we have x to the power 2, and that means parabola. So we have WL square by 2 over here. And then as bending moment increases, slope decreases. So our slope will be decreased, and we are in this fashion. So this is WL square by 2, and this is x to the power 2. Try to understand this polynomial function. For concentrated load, shear force diagram is constant. Then bending moment linear. For UDL, shear force diagram is in linear, x to the power 1. And bending moment diagram, x to the power 2. Bending moment increases, slope decreases. Slope decreases. Here we have WL square by 2 negative value. And therefore it is decreasing. And we are going to get it as 0. Then we have couple. If I will draw a couple, sometimes this question asked and students are not in position to plot it. So I will plot couple over here. Draw BMD for couple. So we have, let us, you can consider anyone. So this is M, this is L. Now if you will find the reactions, then you are going to get first value will be in this fashion. This will be M. Now we have reaction over here, R. So now simply apply summation fx equal to 0. And if you apply summation fx equal to 0, then you will get value of R equal to 0. And therefore, no reaction will be developed. And we have, this will be my SFD for couple. Now plot BMD for couple. And then you are going to get BMD. So we have M over here, downward. And then no moment over here. And then we have this will be x to the power 0. Value will be M. And this is my BMD. So this we have value M minus. So we should know when we will apply couple. So my SFD will be constant. And we are in this fashion. And then we have last load, that is UVL. So I will plot for UVL. So we are being in this fashion. So we have likewise. Now we have W over here. We have L over here. Now what will be my reaction? Now my reaction I will plot. So we have this reaction will be WL by 2. Area of load diagram. Here in UDL, we have rectangle. So what will be area of load diagram? W into L. Now this is triangle. So what is area? So we have 1/2 W into L. So WL by 2. What will be bending moment over here? So total load we have act at this. This total load is WL by W, sorry, not L square. So we have WL by 2. And where it will act? So it will act at L by 3 from right angle. So this is WL by 2. And we have this will be L by 3 from right angle. And we will get it as WL square by 6. Now first we will draw SFD. Now how we will plot SFD? So we are in this fashion. Now we have to draw couple. Now you can see in first part, decrease we have large. So if load decrease, we have slope decrease. Means our diagram for UVL will be in this fashion. And this is x to the power 1. This is parabola, keep in mind. If we have UVL in this fashion, then what will be my curve in this case? So my curve will be in this case, curve will be like this. Now see why. You can see in this portion, we have load is less. And here you can see decreased is less. Now, if we will consider end portion, so you have load larger, this portion, and then we have like this. Decreased is large. And here in the starting portion decrease less, and you can see, sorry, large, and you can take line and you will get larger portion will be decreased. And in end portion, we have lesser portion will decrease. And therefore, whenever you have load decreases, slope decreases, load increases, slope increases. And you can see this is slope increasing. You draw horizontal line, you draw tangent theta. You can see this. So your theta value goes on increasing. And then we have bending moment diagram. And bending moment diagram, we do not have option. This is parabola x to the power 2. Sorry, this is x to the power 2 because already we have this as x to the power 1. And then if we will go with this parabola, and then we have in this fashion, which is x to the power 3. And value we have WL square by 6. Now you may ask what is difference between parabola and cubic parabola. You cannot differentiate. If you plot values, then you will get difference between the two. So we have in this fashion, while in this case, if we will see bending moment, then bending moment, your value of WL by 2 over here, and it will be at 2L by 3. And therefore, in this case, my value of bending moment will be WL by 2 into 2L by 3, which will be WL square by 3. And then we have bending moment in this fashion, which is WL square by 3. So likewise, we have to go for the SFD, BMD. These all are related with your cantilever. Now we will see next, which are related with your simply supported. Now in simply supported, we will consider first concentrated load at center, generally asked standard cases. So we have this will be UD, this will be simply supported beam. So just a minute, it will going. So simply supported with concentrated load at center. So simply supported. Now you have used this in your practicals. You may ask for which practicals you have considered this diagram. So we have this will be P. This will be L by 2. This will be L by 2. As it is symmetrical, so what will happen? My reaction are equal. So we have P by 2 and P by 2. And then we have to find SFD and BMD. So he will ask to draw SFD, BMD. Then we are going to say, can we use calculator? Values are not given. These are variable loads. And then we will go up P by 2. So we have this will be P by 2. Then no load is there. Then we have to go below P. P by 2 we have up. And then we have to go P by 2 down. So you can see this is again P by 2. So total ordinate, if we will see at this, then we have this total ordinate that is equal to P. So we are going up P by 2, then we will go P below. So P by 2, P minus P by 2, minus P by 2 will go down. Then no load we have over here, and then we have 0 over here. So this is minus plus, we have this as SFD. Now no load between A to C, and no load between C to B, and therefore we have over here x to the power 0. Now you can go for BMD, and in BMD you can see we have concentrated load at center, and then if we will plot it, then we are going to get it as P by 2 into L by 2, and this will be PL by 4. So we have this value as PL by 4. So we have PL by 4. So just I will draw a horizontal line, it gets. So try to draw it. Yes. So we have this will be PL by 4 plus. We have this as P by 2 into L by 2 at C. And this will be PL by 4. That is a one. Now if we will go to UDL, then what will happen in this case? So we have UDL. So now I will draw with UDL. So we have simply supported and then with UDL. So let we have this UDL will be W, L will be span. And then what will be my reaction? Total load, area of load diagram is W into L as symmetrical. So we have half WL by 2, WL by 2. And then you draw SFD. So how we will get this SFD? So we will go with SFD. So we have to go up over here. So WL by 2 we will go up. This is x to the power 0. So automatically I will get x to the power 1. So WL by 2 minus W into L. And then we will get it as minus WL by 2. So you will draw it and then you will have 0 over here. So this is plus, this is minus. We have this as WL by 2. We have this as WL by 2. And this will be SFD. And then we have third diagram which is BMD. And then we have third diagram we will plot. So we have third diagram as BMD. Now you can see this is x to the power 1 and we have x to the power 2. As we know, bending moment increases, slope will decrease. So we have in this fashion, what will be value? WL square by 8. These standard cases you have to remember. And then we have over here, as bending moment decreases, your slope should increase. And we have this will be, you can plot above the line or you can plot below the line, doesn't matter. So we have this will be BMD. So we have BMD. This is second. Now if we will go to the third case, which we have seen in concentrate your cantilever beam. So that is couple. Then what will happen for couple? Now try to understand this. We do not have same no diagram over there. No. So this is M. We have L by 2 and we have L by 2. Now in this case, you do not have reaction 0 because what will happen in this case? If I will take moment about B0. So moment about B equal to 0, then we have, so if I will say VA, so we have VA into L clockwise plus M clockwise equal to 0 and VA is minus M by L. And then apply Fy 0. So we have VA plus VB equal to 0. No moment in force equation because we have force equation and moment as unit Newton millimeters. And therefore VB is M by L because VA is minus, goes on right side, becomes plus. So we have value of reaction over here. VA, this is M by L, and VB, we have upward M by L. And now if we will plot it, then it will come down M by L. No load between over here. And then we have this will be M by L. So we have difference in bending shear force diagram. If we will talk about couple in cantilever and couple in simply supported. And then what will be bending moment diagram? This is again important one. Now, if we will try to bending moment diagram, then what we will get it as, we have, due to this, we have m by l into l by 2 just left. Then what will happen? LL gets cancelled. It will be m by 2, and then we can plot it as m by 2 below. Then we have m over here. Then we have to go up, which again m by 2, and then we have m by 2, and then we have value 0 over here. So my value will be in this version. So this is my SFD, and then this will be my BMD. And then last case we will see, which is related with your UVL. And then in UVL, you can see we have two UVL. Then one I can say that is your value of the load that is increasing, and other we have load is decreasing. Now first we will consider value that is of load is increasing in this mesh. So we have likewise. Now he may ask you what are the reactions. If this is W, this is L, and then this is VA, this is VB. We should be in position to find reaction. How we will find reaction? We will apply total load. What will be my total load? So we have total load will be WL by 2. And distance from this is 2L by 3. So we have this distance 2L by 3. So we have 2L by 3 from here. So this is 2L by 3. And then we have moment about B equal to 0. And then, or we will say better A, because A we have distance already mentioned. So we have VB, that is minus VB into L, plus WL by 2 into L 2L by 3, and that is equal to 0. 2 gets cancelled. We have VB equal to WL by 3. So we have VB WL by 3. And you can take moment about B0. Then what will be value? So VA we will get it as WL by 2 into L by 3, which will be WL by 6. So we have VA WL by 6. These are standard. If it is reverse, if you have this UVL in reverse manner, so we have like this, then our left value will be WL by 3 and right value will be WL by 6. Then we have to go for SFD and BMD. So we have now SFD. So we will go with SFD. We have to go up. How much? WL by 6. And this is x to the power 1. So in SFD, as load increases, our slope should increase. And then we have this value as WL by 3. So we have this as WL by 3. And slope should increase. And my curve will be in this fashion. Slope is increasing. And then it will be 0 over here. If we will draw over here, what is happening in this case? You have WL by 3. Load is decreasing. And as load decreases, slope also decreases. We have diagram in this fashion. And then it will be WL by 6 over here. And then we have third. And third we have, that is for BMD. And then we have for BMD this value. Bending moment, we have at A 0. And then at B, we have 0. And then we have value in between. Maximum will be at slope equal, your shear force equal to 0. And we will get in this fashion. Now this value you have to plot. I will not go in detail with this. So you can ask them, we have to calculate it. We have to find shear force 0. You have to consider this as x. And then you have to write shear force equal to 0. If I will write shear force equal to 0, then what we will get? WL by 6, which is VA minus 1 half. Then we have to consider this as W1, and we have W1 by X equal to W by L, which will gives me W1 is equal to W by L into X. This is W1, this is vertical. So we have half W1 into X, and W1 we have to put. So WL by 6 minus 1 by 2 W by L into X equal to 0. And from this we have WL by 6 equal to Wx square by L, 2L. And then we have W gets cancelled, 2 3s are 6, and we have x square is equal to 3L square, and we have x equal to root 3 into L. And then at that point, you have to go for bending moment. Nature you keep in mind. Here we have x to the power 1. Here we have x to the power 2. And here you have x to the power 3. Same way, here bending moment diagram will not be changed. X to the power 1, x to the power 2. And then we have this will be x to the power 3. So these SFD BMD diagrams, you should be in position to plot it. So that is most important one. Now we will stop here only. Thank you.